When choosing a computer, two considerations are paramount: processor speed and memory speed. The processor runs programs or completes tasks, but storage capacity in the form of random access memory, RAM, is required for those programs to perform at their optimal level. Therefore, a fast processor is only useful when combined with fast RAM. However, in the past 3 decades, whilst processor speed has increased at a rapid annual rate of 55%, memory speed has only risen by 10% per annum. Another hurdle to improvement is seen in the interconnect bottleneck. The performance of computer systems is limited because circuits have been downscaled to such an extreme degree. This means that the wires linking transistors are so tightly packed that parasitic capacitance grows, causing significant delays in signal transmission. However, more recently, academia and industry have been replacing old metallic interconnects in their high-performance computing systems with optical ones. Not only does this offer far greater speed of transmission, but parasitic capacitance is rendered impossible. Whilst the interconnect bottleneck problem has been solved by photonic technology, the same cannot yet be said of breaking through the memory wall. For more than 30 years, optical RAM has remained only a dream in the world of photonics. The fundamental reason for this has been the difficulty of storing light due to the absence of any charge. RAMPLAS is a 3-year EU 7th Framework Programme, FP7, funded research project that launched in September 2011. Headed by the Centre for Research and Technology, Hellas, CERT, in Greece, the consortium comprises the Institute of Communication and Computer Science, ICCS, also in Greece, the Technical University of Berlin in Germany, Phoenix Software from the Netherlands, and VTT and Tampere University of Technology in Finland. The initiative aims both to develop and demonstrate an optical RAM chip that will enable high-speed applications in computing and communications. Essentially, the researchers aim to replace electronic RAM with optical RAM, storing light instead of electrons. RAMPLAS's 4 key objectives are: to establish a firm theoretical foundation for optical RAM circuitry, to design and fabricate silicon-based optical RAM cell architectures for 100 GHz on-chip operation, to introduce novel reconfigurable cache mapping and management algorithms and memory organization schemes, to realize highly integrated and high-capacity complementary metal oxide semiconductor (CMOS) compatible 64-bit optical RAM designs. In fulfilling these goals, previously impossible RAM designs and technology will become possible, enabling unprecedented processing power. This could lay the foundations for novel processor memory organization schemes and the most energy-efficient computing architecture ever seen. The optical 100 GHz RAM technology, envisaged by RAMPLAS, is expected to enable unique possibilities in chip multiprocessor design, and therefore the everyday computer user, including higher speeds, ultra-fast memory access times, 30 times quicker than state-of-the-art SRAM, and 3 orders of magnitude quicker than DRAM. Low power consumption. Memory power consumption lower by 50% compared to advanced electronic RAM. Low footprint. The potential for reconfigurable cache mapping algorithms that can additionally reduce power consumption and accelerate performance. The possibility of using wavelength as a new means for interconnecting, which opens untold potential in computing. RAMPLAS's optical RAM technology will mark a new era in computing, the application of which being limited only by the imagination.